By 1944, Germany was already losing the war. Its industry was collapsing, its armies were retreating, its resources were running out. But instead of building simpler, more reliable machines, it chose to build something bigger, heavier, more powerful, more complex, the Tiger II, the most heavily armored tank of the war, a machine designed to dominate the battlefield and restore Germany's advantage. But it didn't, because while the Tiger II looked unstoppable, it demanded more than Germany could give. More fuel, more maintenance, more time. And in a war Germany was already losing, that cost was devastating. The King Tiger's origins are quite prosaic, dating back to 1942, around the time of the debut of its predecessor, the Tiger I. Despite the Tiger I's 8.8 kWk-36, the most powerful tank gun in the world at the time, the Wehrmacht deemed it necessary to upgrade its heavy tanks with KWK-43L71, also an 88mm gun, but with a longer barrel and consequently greater armor penetration. However, the new gun was unavailable for installation on the existing Tiger I, as was the case with other German armored vehicles. The Germans attempted to solve the problem by mounting the KWK-43L71 gun on a self-propelled mount, essentially creating a self-propelled gun. This is how the Wehrmacht developed the Ferdinand self-propelled gun, which saw action as early as 1943 in the Battle of Kursk and Operation Citadel. However, this half measure was clearly insufficient, and in August 1942, the 6th Department of the Armament Directorate, Waprüf 6, issued technical specifications to Nibelungenwerk under the direction of Ferdinand Porsche and Henschel under the auspices of Dr. Erwin Adders to create a fully fledged heavy tank armed with the KW-43L71 gun, which became known as the King Tiger. The Tiger II featured a classical layout with the driver's compartment in the front, the fighting compartment in the center, and the engine compartment in the rear, while the transmission was positioned in the front. The tank had all-around anti-shell armor protection and combined armament consisting of a cannon and machine guns, with the main gun mounted in a fully rotating turret. Its crew consisted of 5 men, the driver and radio operator, located in the front compartment, and the commander, gunner, and loader positioned in the 3-man turret. In terms of protection, the Tiger II was one of the most heavily armored production tanks of World War II. The hull and turret were constructed using a minimal number of armor plates to both improve protection and simplify manufacturing. The hull itself was made from 6 armor plates, all welded together using complex joint methods such as interlocking joints and dovetail connections. The armor material was high carbon, 0.44 to 0.50% carbon rolled homogeneous steel. By late 1944, due to the loss of access to non-ferrous metal resources, German industry faced shortages of alloying elements. As a result, the content of elements such as molybdenum was reduced and partially replaced by vanadium. Molybdenum provided toughness to the steel, while vanadium increased elasticity. This substitution negatively affected armor quality compared to earlier Tiger I tanks. Laboratory analysis conducted at Central Research Institute 48 noted a gradual decrease in molybdenum content in German tanks, such as Panzer IV and Panzer V Panther, on which there are videos on the channel, and its complete absence in Panzer IV Ausführung B. The study concluded that the replacement of molybdenum with vanadium was likely due to depletion of reserves and the loss of supply bases. It also highlighted that the armor of the Tiger II had relatively low toughness compared to Soviet armor, which was more ductile. In practice, this meant that despite its greater nominal thickness, Tiger II armor was more prone to brittle failures, such as spalling and cracking under impact, even without full penetration. The effectiveness of the armor design relied heavily on the use of steep angles. The upper frontal plate, 150 millimeters thick, was set at an angle of 50 degrees from the vertical, providing a theoretical line-of-sight thickness of approximately 233 millimeters. The lower frontal plate, 120 millimeters thick, was inclined at a similar angle, but in the opposite direction. The upper side plates, inclined at 25 degrees, lower side plates, vertical, and rear plate, inclined at 30 degrees, all had a uniform thickness of 80 millimeters. The hull, bottom, and roof were 40 to 42 millimeters thick. The Tiger II was initially equipped on the first 50 vehicles with a turret designed by Porsche. This turret had a streamlined shape, with a distinctive feature being the base of the commander's cupola protruding beyond the side wall. Its frontal armor was 107 millimeters thick at an angle of 10 degrees, while the sides and rear were 80 millimeters thick at 20 degrees. Although the overall shape was considered effective, it had a critical flaw. The rounded front created a shot trap, causing incoming shells striking the sloped armor to deflect downward into the relatively thin hull roof. The later turret, designed by Adders, had a simplified construction and eliminated this flaw. Additionally, its frontal armor thickness was increased to 180 millimeters at the same 10 degrees angle. The main armament consisted of an 88 millimeters KWK-43 L71 gun mounted on trunnions in the turret front plate. Due to its large size and weight, the gun required a reinforced platform. The turret ring diameter was increased to 1850 millimeters, and significant internal space was reserved in the front of the turret to accommodate the forward-mounted trunnions. The gun was protected by a mantelet with armor thickness ranging from 65 to 100 millimeters on both turret types. To counterbalance the heavy front and facilitate the loader's work, a large rear bustle was added, housing ammunition stowage for 22 rounds. Despite the gun nearly dividing the turret in half and extending close to the rear wall, the turret remained relatively spacious. The turret traverse was powered hydraulically and could complete a full rotation in 19 to 77 seconds, depending on the engine speed driving the hydraulic system. Manual traverse was also possible, requiring 704 turns of the gunner's handwheel or 680 turns of the loader's handwheel. In addition to ammunition storage, numerous racks for additional equipment were installed inside the hull. The number of openings in both the hull and turret was minimized. A hull-mounted machine gun was installed in a ball mount in the front plate. The driver's and radio operator's hatches were located on the hull roof. The loader used a rectangular hatch on the turret roof, while the commander and gunner accessed the vehicle through the circular hatch in the commander's cupola. At the rear of the turret, a large hatch measuring 520 on 476 millimeters was provided for loading ammunition, ejecting spent casings, emergency crew evacuation, and gun replacement under factory conditions. It also included a firing port for personal weapons. Another opening, circular with a diameter of 230 millimeters, was located on the turret roof above the breech and served for ventilation and removal of propellant gases from the fighting compartment. In 1944, most Tiger II tanks operating on the Western Front were additionally fitted with armored protection over the engine compartment air intake louvers to protect the rear from Allied air attacks. The Tiger II was one of the rare examples in tank design where the vehicle itself was built around its main armament rather than the gun being designed for the tank. This armament was the 88 millimeters rifled tank gun KWK-43L71, developed from the 88 millimeters anti-aircraft gun model 1941 previously used on Tiger tanks. Many experts from both sides of World War II consider the KWK-43L71 to have been the most powerful gun in its class during the war, surpassing most Allied tank guns in both range and armor penetration. The KWK-43L71 was the longest-barreled tank gun ever used by the Wehrmacht, with a barrel length of 71 calibers, 6,248 millimeters, or 6,592 millimeters, including the muzzle brake. The muzzle velocity of its armor-piercing shell reached 1,000 meters per second. At a distance of 2,000 meters and an impact angle of 60 degrees from the armor surface, it could penetrate 150 millimeters of armor. According to German firing tables, at 1,000 meters, the probability of hitting a target the size of a tank, 2.5 on 2 meters, with the first shot was 100% under test conditions and 85% in combat. At 1,500 meters, this decreased to 95% and 61%, and at 2,000 meters to 85% and 43%, respectively. These high-performance characteristics came at the cost of large size and mass. The gun itself weighed 605 kilograms, while the complete installation with mantelet weighed 265 kilograms. The high-velocity design also led to significant barrel wear, and as a result, later production guns used a two-piece barrel. Another issue was the large size and weight of the unitary ammunition, with each round weighing 23-24 kilograms, which necessitated placing ammunition as close to the gun as possible. The gun was mounted on trunnions in the front of the turret and balanced by a special mechanism located to the right of the gun inside the turret. Horizontal aiming was achieved by rotating the turret, while vertical aiming, ranging from -8 degrees to +15 degrees, was performed manually using either a screw or electric mechanism, depending on the control lever position. The firing mechanism was electrically operated and equipped with a safety device. The ammunition types included armor-piercing capped ballistic, capped Panzer granate 39-43, projectile mass 10,016 kilograms, propellant charge 6.8 kilograms, muzzle velocity 1,000 meters per second, subcaliber armor-piercing Panzer granate 40-43, projectile mass 7.3 to 7.5 kilograms, propellant charge 6.8 kilograms, muzzle velocity 130 meters per second. High explosive, Spreng granate 43, projectile mass 9.4 kilograms, propellant charge 3.8 kilograms, muzzle velocity 750 meters per second. And heat, GAR 3943HL, projectile mass 7.65 kilograms, propellant charge 2.0 kilograms, muzzle velocity 600 meters per second. German penetration data for rolled homogeneous armor indicated that the Panzer granate 39-43 could penetrate 239 millimeters at 100 meters, 226 millimeters at 500 meters, 211 millimeters at 1,000 meters, 202 millimeters at 1,500 meters, and 190 millimeters at 2,000 meters at a 0 degrees angle, and 215 millimeters, 203 millimeters, 189 millimeters, 178 millimeters, and 166 millimeters, respectively, at 30 degrees. The Panzer granate 40-43 could penetrate 260 millimeters at 100 meters, 250 millimeters at 500 meters, 240 millimeters at 1,000 meters, 230 millimeters at 1,500 meters, and 220 millimeters at 2,000 meters at 30 degrees. These values were based on German testing methods, which differed from those used in other countries. The gun was equipped with a bore evacuation system using compressed air. Initially, compressed air from a compressor located under the gunner's seat was fed through two nozzles near the breech ring. Later, a compressor-less system was introduced, using air pressure generated by the recoil energy of the gun. This system effectively removed residual propellant gases from the barrel and reduced fumes inside the fighting compartment. Ammunition was stored in racks located in the hull sponsons within both the driver's and fighting compartments, as well as in the turret bustle. The Porsche turret stored 16 rounds, while the Henschel turret held 22 rounds. Total ammunition capacity varied between 72 and 77 rounds for tanks with the Porsche turret, and between 80 and 84 rounds for those with the Henschel turret. The ammunition load typically consisted of an equal ratio of armor-piercing and high-explosive rounds. Secondary armament consisted of 2 or 3 7.92 mm machine guns. One MG-34 was mounted coaxially with the main gun, while another MG-34 was installed in the hull front in a Kugelblende 150 ball mount, allowing vertical movement from -10 degrees to +15 degrees and horizontal movement of ±5 degrees. It was aimed using a KZF-2 telescopic sight with 1/18 cons magnification and an 18 degrees field of view. A third machine gun, usually an MG-42, could be mounted on the commander's cupola using a Fliegerbeschussgerät 42 anti-aircraft mount. On some later tanks, the coaxial MG-34 was also replaced by an MG-42. The total machine gun ammunition load amounted to 550 rounds, stored in 39 belts of 150 rounds each. As additional armament, the Tiger II was equipped with a 26 mm Nahkampfgerät close defense mortar mounted on the right side of the turret roof. It was supplied with smoke, high explosive, and fragmentation incendiary rounds, and was intended for defense against enemy infantry at close range. The Tiger II was equipped with a fire control system that evolved during production. Early vehicles used the binocular articulated telescopic sight TZF-9D1, later replaced by the monocular TZF-9D. The TZF-9D-1 provided variable magnification of 3 tanks with a 26 degrees field of view, or 6 tanks with a 13 degrees field of view, while the TZF-9D offered 2 and 5 tanks magnification with a 25 degrees field of view, or 5 tanks with a 12.5 degrees field of view. The sight was calibrated for armor-piercing fire up to 3,000 meters, high explosive fire up to 5,000 meters, and coaxial machine gun fire up to 1,200 meters. The high optical quality produced by Carl Zeiss enabled accurate hits at ranges of 2,500 meters and occasionally beyond. Observation equipment included vision devices for the driver and radio operator mounted in the front of the hull roof, protected by U-shaped brackets. A cutout in the upper left part of the frontal plate improved the driver's field of view. The turret roof carried a standard late-war German commander's cupola with 7 vision blocks, providing good all-around visibility. Although in practice, the commander often preferred to observe with his upper body outside the hatch while on the move. All vision slits were protected by armored glass. A headlamp with a blackout cover was installed on the frontal armor plate to the left of the hull machine gun. The tank was fitted with a standard FUG-5 radio set with a power output of 10 watts, operating in the 27,200 to 33,000 kilohertz frequency range and providing a transmission range of up to 4 kilometers. Command variants carried additional communication equipment. SDKF set 268 vehicles, intended for company-to-battalion communication, were equipped with the FUG-7 radio, 20 watts, 42,100 to 47,800 kilohertz, range up to 30 kilometers, while SDKF C-267 vehicles, used for regiment-to-division communication, carried the FUG-8 radio, 30 watts, transmitter frequency 11130 to 3,000 kilohertz, receiver frequency 580 to 3,000 kilohertz, range up to 10 kilometers. For internal communication, all tanks were equipped with a standard intercom system serving 5 crew members. The Tiger II was powered by a Maybach HL230 P30 engine, a V-shaped 12-cylinder, 4-stroke liquid-cooled gasoline engine with a displacement of 23,095 cubic centimeters. It produced a nominal maximum output of 700 horsepower at 3,000 revolutions per minute, although in practice, engine speed rarely exceeded 2,500 revolutions per minute, reducing actual power output. Operational manuals listed the engine's effective power as 600 horsepower at 2,600 revolutions per minute. The engine was mounted longitudinally in the rear engine compartment. Its fuel system consisted of 7 interconnected fuel tanks with a total capacity of 860 liters, filled through a single filler neck. 5 tanks were located in the engine compartment, while the remaining 2, with a combined capacity of about 340 liters, were placed in the fighting compartment beneath ammunition stowage. The cooling system included 4 radiators with a total capacity of 114 liters, arranged in 2 pairs and positioned on either side of the engine. Later variants were fitted with an experimental X-shaped 16-cylinder diesel engine developed by Simmering specifically for the Tiger II. The base version produced 960 horsepower at 2,000 revolutions per minute, while the F modification reached approximately 1,200 horsepower due to improved component efficiency and the addition of turbocharging. The transmission system included a drive shaft connecting the engine compartment to the transmission, a multi-disc main clutch with oil-immersed friction surfaces integrated into the gearbox, and a 12-speed 8 forward, 4 reverse Maybach OOG 4012-16B gearbox of shaftless design with constant gear mesh, central synchronization, and individual brakes. A parking brake was also integrated into the gearbox. Steering was achieved through a dual-flow mechanism of the double differential type, model Henschel L801, providing 16 fixed turning radii forward and 8 in reverse, with 2 per gear, and allowing neutral pivot turns about the tank's center of mass. Final drives were double-row combined units with an unloaded driven shaft, and braking was handled by mechanical disc final brakes of the Argus Motoren LB900 4 type. A servo-assisted control system allowed gear shifting with a single movement of a lever on the driver's panel, automatically disengaging the main clutch and previous gear, synchronizing and engaging the new gear along with the clutch. In the event of servo failure, manual gear shifting remained possible. The transmission had a separate lubrication oil cooling system, with its radiator located in the fighting compartment. Water circulation within this radiator was not used. Instead, the water had to be manually replaced when necessary. The running gear of the Tiger II on each side consisted of 9 double road wheels with internal shock absorption, a rear idler, and a front drive sprocket, with no return rollers. The road wheels were stamped 800 millimeters in diameter, with each individual wheel having a width of 95 millimeters. The suspension was individual torsion bar type, with the first and last road wheels equipped with hydraulic shock absorbers mounted inside the hull. The wheels were arranged in an interleaved pattern, with 5 wheels supporting the outer track run and 4 supporting the inner run. The tank used 73-800-152 steel tracks of fine link, double pin engagement design, each consisting of 92 links with a width of 818 millimeters and a pitch of 152 millimeters. Each track was made up of 46 double-tooth links and 46 flat links arranged alternately. In addition, transport tracks could be fitted to reduce the vehicle's width for rail transport. These were kilograms 73 to 6660 at 152 tracks with a width of 658.5 millimeters, the same type also used on the Panther tank. Despite the overall increase in combat weight and a reduction in power-to-weight ratio compared to the Tiger I, the design of the running gear allowed the Tiger II to maintain acceptable cross-country mobility. The use of wide tracks reduced ground pressure from 1,009 to 1.06 kilograms square centimeters. The tank was capable of climbing slopes up to 35 degrees, crossing trenches up to 2.5 meters wide, and overcoming vertical obstacles up to 0.85 meters high. It could ford water obstacles up to 1.6 meters deep without preparation. However, its operational mobility remained limited, due in part to the requirement to change tracks for railway transport, and the crossing of water obstacles remained a difficult problem throughout the war. The first combat use of the Tiger II on the Eastern Front took place on the 13th of August 1944 in the area of the Sandomierz bridgehead near the village of Oglendo, where the 501st Heavy Tank Battalion was committed to battle. As with the earlier Tiger I, the debut proved unsuccessful. In the engagement near Oglendo, 2 T-34-85 tanks destroyed 3 Tiger II tanks from an ambush and damaged a 4th. Soviet forces in this sector had anticipated an attack by heavy German tanks and prepared a combined tank artillery ambush that included, among other weapons, 122mm A-19 guns and ISU-152 heavy self-propelled artillery. During combat with the 53rd Guards Tank Brigade, German sources reported 11 tanks lost, while Soviet sources claimed 13. Over 3 days of continuous fighting from 11 to 13th August 1944 in the areas of Stashov and Shidwal, units of the 6th Guards Tank Corps captured and destroyed 24 enemy tanks, 12 of which were Tiger II. 3 Tiger II tanks, turret numbers 102, 502, and 234, were abandoned by their crews and captured intact. According to a Soviet participant, a group of T-34-85 tanks emerged from a forest onto a field where Tiger II tanks had become bogged down approximately 20 centimeters into the ground, losing mobility. The T-34-85s rapidly closed the distance, mingled with the immobilized tanks, and opened fire while the Tiger II turrets could not rotate quickly enough. As a result, the German crews abandoned their immobilized vehicles without destroying them. Tanks numbered 102 and 502 were transported to Kubinka for comprehensive testing, and one of them remains on display there today. At the same time, the 1st Guards Tank Brigade under Colonel Gorolov of the 8th Guards Mechanized Corps reached a forest near Khmelnyk. A battalion under Guards Major Zhukov encountered 16 German tanks at night, whose crews were sleeping in a nearby house. Only 3 German crews managed to reach their vehicles. As the German tanks attempted to maneuver, T-34 fire disabled their tracks, and the tanks were captured fully fueled and with complete ammunition loads. These vehicles were subsequently transferred to the 3rd Battalion, which had spare crews available. The last recorded destruction of a Tiger II in combat is considered to have occurred in Berlin on the 2nd of May 1945 in the area of the Spandau Bridge. On the Western Front, The Tiger II was first issued to the 316th Company of the Panzer Lehr Division, which received its first 5 production vehicles on the 14th of March 1944. These tanks were used exclusively for training purposes and were ultimately destroyed to prevent capture by advancing Allied forces. The first operational combat unit equipped with the new tanks was the 503rd Heavy Tank Battalion. Due to production delays, it received only 12 Tiger II tanks, while the remaining 33 vehicles were Tiger I. The battalion was deployed on the 27th of June and arrived in Dreux on the 7th of July, where it was attached to the 22nd Tank Regiment of the 21st Panzer Division, engaged in combat against British forces near Caen. In its first engagement, the battalion knocked out 12 Sherman tanks. On the 18th of July, during Operation Goodwood, its positions, along with other German forces near Caen, were subjected to a massive air bombardment. Combat experience demonstrated the high effectiveness of the Tiger II, which proved largely invulnerable from the front to available anti-tank weapons. Even the latest 90mm guns of the M36 tank destroyer and the 76.2mm QF-17 pounder showed limited effectiveness against it. As a result, massed fire from field and heavy artillery was frequently employed. Nevertheless, the battalion gradually lost tanks both in combat and due to mechanical failures, and by 6th of August, only 11 vehicles remained operational. The 3rd Company was withdrawn for re-equipment with 14 Tiger II tanks delivered between the 27th and 29th of July. From 12th of August, the battalion fought in the area of the Orne River, but during subsequent engagements and the retreat in August-September 1944, 12 of these 14 tanks were lost, primarily due to breakdowns or the inability to cross rivers. Only 2 tanks were eventually returned to the rear to equip new units. The 101st SS Heavy Tank Battalion received 14 Tiger II tanks for its 1st company between 28th of July and 1st of August to replace combat losses, but all of them were soon lost during the fighting and retreats of August and early September. On the 9th of September, the battalion was withdrawn for re-equipment, with plans to arm 2 companies with Tiger II tanks and 1 with Jagdtiger vehicles. These plans were cancelled by a direct order from Adolf Hitler, who prohibited mixed heavy tank battalion structures. Deliveries of Tiger II tanks were delayed due to production issues, but between 17th of October and 3rd of December, the battalion eventually received 34 tanks, and together with its remaining Tiger I vehicles, returned to the front on the 5th of December. It was attached to the 1st SS Division, Leibstandarte Adolf Hitler, took part in the Ardennes offensive, and ultimately surrendered with it on the 9th of May 1945. The 1st Heavy Tank Battalion to be fully equipped with Tiger II tanks was the 506th, which received 45 vehicles between 20th of August and 12th of September. On the 22nd of September, it was sent to the front in the Netherlands to counter the British offensive. The battalion fought across multiple sectors until spring 1945, including participation in the Ardennes offensive. By 5th of April, only 7 operational tanks remained, and on 4th and 15th of April, the battalion surrendered along with other German forces encircled in the Ruhr. In March 1945, the 507th Battalion was withdrawn from the Eastern Front and received 21 Tiger II tanks for operations in the West. It did not take part in combat as it was ordered to retreat toward Plzeň to surrender to Anglo-American forces. But advancing Soviet troops cut off its route, and on the 12th of May, the battalion surrendered to Soviet forces. An additional 16 Tiger II tanks, including the last 13 produced vehicles taken directly from the factory, were issued to the 3rd Companies of the 510th and 511th Battalions, which from 1st April fought in the Kassel area. In the final months of the war, all available Tiger II tanks were committed to combat in various units, including those previously allocated for training or testing, as well as even the Porsche Tiger prototype. To sum it up, in my opinion, the King Tiger is a frankly disastrous vehicle. Sure, in a theoretical 1-at-1 tank duel, the Tiger II could defeat all Allied tanks, but far from all. The IS-2, which appeared a couple of months earlier, should have always emerged victorious in a duel with the German Cat, but such duels only occur in tank shooters like War Thunder. In reality, such cases are almost never seen. In our world, tanks, like everything else, are primarily a vehicle for infantry support, alongside artillery, aviation, and other branches of the armed forces, which act as a single military mechanism in battle. And under these circumstances, the King Tiger has changed its crown. Low mobility made the vehicle extremely vulnerable to Allied artillery and tanks, as history has clearly demonstrated. Meanwhile, armor thickness becomes irrelevant during air and artillery strikes, whose shells and bombs almost never hit the tank directly, but whose close-in explosions can destroy observation devices, damage the chassis, and other components, rendering the tank inoperable without destroying it. At the same time, the Tiger II's gun, while very powerful in terms of armor penetration, had a much smaller caliber than the IS-2's 122mm gun, and as a result, its high explosive shells were significantly weaker. Adding to the already dismal picture is the traditionally low reliability and difficult maintenance of German heavy tanks, this time exacerbated by the overloaded suspension of the Tiger II, which, as a reminder, weighed up to 70 tons, compared to 46 tons for its Soviet competitor. It's already clear that even on the battlefield, the Royal tank, while superior to its predecessor, the Tiger I, was not by much, and in some places was inferior. And now, to complete the joy, let's remember that war is, first and foremost, a battle of economies. As I say in all my videos, it's not the most powerful military equipment that wins, but rather the one with the most balanced combat effectiveness and ease of production. Simply put, the notorious price-quality trade-off. And here, the Tiger Cub situation is again dismal. The price in Reichsmarks was approximately 322,000, but most importantly, the tank required over 300,000 labor hours to assemble, which was approximately 1/5 higher than the Tiger I and twice the production time of the IS-2. Simply put, for every German Tiger II, the USSR was producing 2 more advanced heavy tanks. Moreover, the transition to the new vehicle again caused difficulties and a decrease in production rates. While at its peak, the Reich's industry was producing just over 100 Tiger Is per month. By the time of the full transition to the Tiger II, it was able to produce fewer than 90 tanks at its peak. Thus, the last German cat became not a saving Wunderwaffe, but another nail in the coffin of the dying Third German Empire. That's where our story ends. If you liked it, please like and subscribe to the channel. It really helps me grow it. Also, please leave your comments with your opinions on what you've heard. And until next time,